to calculate the mass required to prepare a certain volume of a solution of a known concentration. A very common question in the GCSE chemistry exam. This is a question from a past paper where they give you the volume the student prepared, which is 250 centimeter cubed, and they give you the concentration, which is 0.05 mole per decimeter cube. And they ask you to calculate the mass of acetic acid required to prepare this solution. To answer these type of questions, you need first to keep in front of you the two triangles that relate the number of moles with the mass and the MR, and also the one that relates the number of moles with concentration and volume. So the first one here is this triangle where the number of moles, which is N, equals mass in gram over the MR, which is the relative molecular mass. And the other one is the one that relates the concentration as C, which equals the number of moles over the volume in decimeter cube. So now let's answer this question. First of all, you need to find the MR of the citric acid based on the information you are given in this question. They give you the molecular formula of citric acid and the relative atomic masses of all of the elements. So MR of citric acid will equal 6 times 12 because there are 6 carbons plus 8 times 1 for the 8 hydrogen plus 7 for the oxygen because there are 7 oxygen times 16. That will give you 192. This is the MR of citric acid. Now we need to find the number of moles of citric acid in the prepared solution using the second triangle. So number of moles will equal the concentration times the volume in decimeter cube. The concentration here is 0.0500 times the volume in decimeter cube. They provided you the volume in centimeter cube, so you have to divide this by 1000. So this is 0.250 decimeter cube, and the number of moles is 0.0125 moles. And then finally you need to find the mass. So the mass of citric acid will equal from this triangle, the first triangle will equal the number of moles times the MR. So number of moles is 0.0125 times the MR that we found there, which is 192, and that will give you the mass in gram, which is 2.4 gram. So the mass here is 2.4 grams.